And so our next speaker is Stefan Moese. So this is continuing a theme that you'll see where most of our speakers are named some variation of Steve, continuing through the afternoon as well. So Stefan is at ESBATech. He is the group head screening technology, and they're also relatively new users, adopters of Labkey. Stefan?
Thanks a lot, Josh. I mean, actually, you'll be seeing. It's quite interesting. What we're doing or how we're using Labkey is, I think, totally different to what you've seen today in the morning. I mean, there are some overlaps. I mean, one is Labkey. There's no clinical data so far, and it's a totally different thing. So let me quickly tell you a little bit about. I mean, I'm working for Novartis. I mean, most of you might have heard of this pharma company. We're a small subsidiary, mainly working in ophthalmology, and I don't want to bore you with the ophthalmology a lot, but I'd show you a little bit about the business strategy we're using, and I'm happy to talk about more over coffee or beer or whatever, depending on the time. So what we do, we work in ophthalmology, we generate therapeutic antibodies. They're in a specific format, which is called scFv, so let's not bother about that at the moment. But what I really like to show you is, as you guys know, drug development is quite a complicated process. It follows a lot of steps, and that's what we're doing. So we start with immunizing rabbits, go around that circle, and at the end of the day, if everything goes well, you know, you'd like to manufacture the therapeutic antibody and then test it in the clinics, give it to patients. I mean, that's the idea of the whole enterprise. And so we're at that part where we actually do all of this. There was a need for supporting this process. And I mean, some of the speakers already mentioned Excel. I actually didn't know that story about the wife working on Excel, but interested to hear more about that later. We're also using Excel. It's a great product. Where it gets a little difficult is if you have to work with gazillions of different Excel files at gazillions of different places. And that's actually what we're doing. And so this was part of the reasoning why this is not getting so great anymore if there are too many Excel files. And so let me quickly show you what we do. So we immunize rabbits, then do flow cytometry to isolate a specific type of B cells. In my group, we use a lot of automation, and there's a person from my group running a lot of the automation bioinformatics. Olivier Mauti is sitting in the audience as well, so he'll be happy to tell you more about that part. Oops, that was the wrong button. And so we then, select this certain type of B cells, do a lot of assays, go through a couple of iterations of this, and then have some hits, which eventually then we get the antibodies out and make them even better and hopefully have them as a therapeutic at some point. The next step is to give it to our colleagues who actually produce it, which first in a lab scale and later in larger amounts, which then will go into the final product and into clinical testing. And for all of this, I mean, as trivial as it sounds, I mean, Novartis is not such a small company, right? So you would expect that they have a system to capture all that data, to organize all that data and stuff like that. And actually they do. They have actually plenty of different systems to do that, depending for different purposes. It turns out for therapeutic antibodies, actually they didn't have anything in place. So what we encountered is there are nice systems for small compound research, but for what we needed, there wasn't. So we said, okay, let's first think about what should the system do. So it's more or less trivial, right? You'd like to capture all the assay data in a central place. Ideally, it should be securely. Get an overview about how many molecules do we have at what stage and in the development pipeline, and organize your data via the molecule identifier so that, have a good idea how they're all tied together. And then be able to do comprehensive searches. So like, some of the speakers earlier said, you like to analyze the clinical data sets. We like to do that on the molecules so that we can develop the molecules most efficiently. And then we also like to store the material, of course, and it's great if you find it again. So if it makes it easy to find it, that helps a lot as well. So we came up with Labkey, and we really like this, hybrid. I call it a hybrid solution. I don't know how you guys call it yourself, but this open source commercial solution, because in a in a corporate environment, it's relatively easy, quote unquote, if you have the budget, to buy a ready-made product which is not open source, because your IT department will tell you, yeah, well, you get the support and troubleshooting from these guys because you just bought a product, and you have to buy a contract with it and everything. So if you go to your IT department in Novartis and say, well, there's an open source product, they kind of say, well, anyway. So part of the justification why we actually could explore Labkey was that there's the Labkey company behind, so that the IT department was a little less frightened about that. So let's come to the requirements in a little bit more detail. So Stephen in the talk before already said, instrument raw data, that can be very, very difficult to treat, or very diverse as well. So what we said in the beginning, okay, let's make our lives not more difficult than needed in the first step, because as Josh said, we're quite new to the product. Let's first define what do we really need to have inside Labkey or not. And so we said, okay, let's keep the instrument data as it is. We want to manage the results. Then we do some sample tracking. We have data analysis. There's some electronic data documentation we have to stick to because of QA reasons and all of these things. Then we'd like to easily be able to interface with the data. So we're using R a lot, and I don't know whether you guys know the tool KNIME. It's similar to Pipeline Pilot. Then there's another product which is used quite often, which is Spotfire, to visualize all that stuff. We like to do some workflow tracking. Doesn't have to be an active workflow tracking, can be passive. And then, okay, we like to do some lab management, meaning like freezer inventory and stuff like that. And so what we decided is, so instead of putting all of that in the box for Labkey, we said, okay, let's focus on really the data management part, meaning the results in the beginning. And one requirement was that you could easily interface with it to really get data in and out. Because, as I said before, there are lots of different systems inside Novartis, and one requirement was, okay, it should be easy to integrate into all the other systems. And it doesn't mean it has to integrate online, just means it has to be open, that you can easily get data in and out. And so just to give you an idea, a little bit more detail, what we're doing is, this typical example of an assay where we typically run these assays in 384-well plates, and there are different concentrations of antibodies in here. And the assay essentially tells you the more green you see, the better it is, and then you want to get that analyzed. And this is what we do with R, and which we've automated to get the curves out of each of these experiments. And the thing is, like, all of these stuff was developed, outside of the Labkey, of course. So this is another part where we said, okay, this needs to be able to integrate or easily interface with Labkey. The other thing what I mentioned before is KNIME, which essentially is like, I tend to call it like a Lego for biologists. It's like for a lot of data analysis, you can easily interface with R or other languages, and each of these Lego parts can do certain things, and you can nicely do, analysis of data or all different kinds of things you can think about where you don't want to write an R script. Data handling in R is fine, but you can easily do that here and just shove it and do the file handling inside KNIME, and then the analysis in R, for example. So, okay, let's switch gears a little bit. So some more general things we had to consider, which is like, so what is the system supposed to do? Some of the stuff is really trivial, but of course, you need to really define what you want to have. And a general principle we said is like, typically you have a sample and then a method, and then this method generates new samples, and it also might generate results. And so there are a couple of, and this general principle, we said, sounds trivial, but to get agreement with everybody that this is the general principle we would like to follow, and all experiments should follow these general principle, actually took a while. And so these are specific cases of this general principle, right? So an assay is a sample, a method, and then this assay generates results. Then we have other assays like a purification, where you also generate new samples. And then there are also just trivial things like making aliquots, where you say, okay, you have one sample, you make 10 out of it, so you generate new samples. Another requirement which we had, which is also to a certain extent trivial, but some of the solutions we looked at, some other software solutions, actually couldn't deal with that. So our molecules have a hierarchy, and this hierarchy is really important for us. So this is the ancestor, it goes to 4, and then, you say, out of these 2, I take certain features or properties and then make a new sample out of that. as you see here, most of these systems would represent it like this, so which is of course not the right way. What we wanted to have is that it actually can do a one-to-many and a many-to-one, so like this. And this is what we're using in Labkey now as well. And then the other thing is like this hierarchy goes further, that you have a molecule, this molecule has a certain format, some certain information where it's stored, an assay which generates new information, and then you like to be able to associate a second assay as well, where you say, okay, I've used the same molecule, but I've done a different assay, and this assay then has other properties and things like that again. And you can see here already that they have different levels of hierarchy. And what we had to think about, what is the highest level in the hierarchy, what we needed, and this is because we're working with therapeutic proteins / antibodies, the protein is the highest level of hierarchy. And I don't want to bore you to death here with all the different details, but what we've decided is that we needed several hierarchy levels. One would be the protein, one would be the molecule, which would be, a DNA or something like that. And then from this, you would manufacture a sample. And then the sample actually would be what you would be using in assays, or which would be stored. So the sample is actually the physical material. All of the other stuff is just information. And then the other thing what we also wanted to do, which I mentioned in the beginning, is some workflow tracking. So, and I called it passive workflow tracking because it's mainly just that you like to be able to follow molecules in the development pipeline. And so we said we need a scientific workflow, which is the big picture workflow. Then we have the molecules, and mainly we're using the GPAD assay, and then the different assays. There are about 60 different assays or assay types which we're using at the moment. And there's an operational workflow, which is like, I gave the sample to somebody and then it came back at a different time point or whatever, which is not the scientific workflow. And then, I skipped that one for today because it would be too difficult to explain. And then there's a team-specific workflow. So inside a team, they also have different workflows, and people want to know, have you guys finished the molecule already? Can I take that over or not? And stuff like that. So, and then the other thing is, as I mentioned before, our molecules are following a hierarchy. So, the way drug development is working, it's an iterative process, right? You start with a certain molecule and you try to make it better during that process. And at some point it's ready to go into the clinics. And this is in principle like just, giving you a rough idea how that works in our case, which is like, we start with an antigen and we do rapid immunizations. We go through screening of a lot of candidates, and at some point we select a candidate, go through protein engineering rounds, and then we select a certain candidate and say, well, that could be it. And then it goes through manufacturing optimization. So you're still working with the same molecule, but just have to really figure out how can you produce that efficiently, and that goes to a clinical candidate. So this is this hierarchy I was talking about. The second level then is, each of these triangles represents an assay. So, at each stage, you're doing lots of assays. Sometimes they're the same, sometimes they're different ones. And one of the requirements we had was, okay, well, for example, you'd like to know how efficient is the molecule. So let's just take the red one as an example. So you've done the assay at all the different steps. So what we want to do is to do queries, across hierarchies. So you'd like to know, for example, if you work with this molecule, how did this develop over time in our development pipeline, and how good was it on a specific assay? And sounds trivial again, but this was one of the requirements which we wanted to achieve, and it's actually not that trivial when you look into detail, because you really have to standardize all the assay formats to be able to do that. And getting researchers to follow rules, guys know that it's super easy or not super easy depending, and also in a company environment that's it's quite a big deal actually. This is the data model what we are using inside Labkey at the moment. So we're using the sample sets as our key part where all the different tables go to, and as I said, in principle the data management part is trivial, but it turned out that we needed quite a lot of lists and tables to really get all of this going, because otherwise all the requirements couldn't be fulfilled and all the queries couldn't be done. And we're still in the pilot phase. I'll come to that in a second. So we don't have a rollout this week, would be great, but that probably needs a little bit more time. And this is the way it looks like. So one of the things which we really liked was that you can easily get custom interfaces for the different departments, and that it's easily to customize it for the different needs. And this is the way we're using it. So it's And what I wanted to show you here is, for example, this is a way how we do the passive workflow tracking. So, for example, you can see here we produce molecules in different scales. And then the guys, our colleagues, which are doing, for example, the small scale production, they just have a custom query. And the custom query just looks for all the molecules which have the status open. And that's as simple as the workflow tracking is going, right? So they know, okay, this molecule is open, I need to make it. And when they're done, they upload the data, and then they actively change the status to done. And then it disappears from this query. I mean, it's super simple and cavemanish in a way, but that already fulfills the workflow tracking. And similarly, it's done on different scales and different things in this case. And then just to give you an idea about the hierarchy, what it means number-wise is we typically have about 15 hierarchy levels to come to a development candidate, which is about 50 parent molecules. And then 3 to 4 hierarchy levels before we get a clinical candidate. But then you have lots of children because, in the manufacturing process, there are a lot of things you need to optimize and test. And to give you an idea how that looks in Labkey is like, I don't know how good you can see that, but there's one common ancestor, lots of children. So if you make it a little bigger, you can see it that this is the way it looks like then. And what you really want to do is follow the process. And that goes up, like, as I said, like a lot of different hierarchy steps. The way it is at the moment is, as I said, like we have about 60 different... Oh, that looks funny. Okay, don't try to read it. There are about 60 different assay types we have in the system. Most of them, they're like, as I said, before we had gazillions of Excel files, right? So most of these are an Excel file where it's like you have a molecule identifier and then you have properties. So very simple. But to be able to do queries across different assays, of course, we had to standardize these so that everybody's using the same templates and things like that. And then the way the data looks like is, this, for example, is a typical visualization which people are using. It's like just, for a certain assay. And you can see here, like, easily how the data would look like. And a lot of the times it's like, a lot of the times the data is like this, where there are potential hits, and this is all the noise or the ones which are not interesting, but these are the ones which are interesting. And so these kind of things are done at the moment outside of Labkey. So most of them, they're done with R or KNIME, NR, or combination of Spotfire and things. And we've started to integrate some of these analysis into Labkey now. But this was also one of the things where we're quite happy about, what you can do with the R API and stuff like that. And where we are in the current process is we first said we want to do a pilot project, which, we had a go, no-go decision in August, and we've stretched it a little bit, so it more looks like Christmas. But in this case, that's okay, because we have the time in this case, and the idea was to start an implementation project at the beginning of the year, and then roll out about 3 releases per year. My group is a screening group and the screening team, and we will have a specific screening-specific implementation, because we don't want to just capture the results data, but we also want to capture all the raw data in the system, which makes a huge difference number-wise of data points. So, and this is where we are. And the thing, lots of things ongoing, performance testing and all these things, but for us really it's like, so far we've concentrated on the business logic, and the business logic I think we're pretty happy with, that we can actually build it inside the system. And the huge part for us still at the moment is the usability, because it's like for Ollie and myself it's pretty clear how we can get the data in and out and what it means. And for all of you who are working with the system, knowing what a run group is, fine, yep, at some point you just understand it. But in our case, it's about 100 users we're looking at, and to explain everybody what a run group is can be quite challenging. Just as one example. So we will have to build a lot of custom UI that people really are able to use it. Because the idea really is that, every lab technician, every person in the company is using that, or in that department. And they don't give a shit about Labkey, sorry. But they just want to get rid of their data and just want to get their job done. And so if it gets too complicated, first of all, they will appear at Ollie's and my desk, which can be nice, but also annoying. But second of all, of course, it needs to be kind of efficient, because you don't want to hold up everybody. And so this is really a huge part of what we have to be working on. These are the people. Ollie is here. He's sitting there in the back. And happy to answer questions to you guys as well. These are the main people involved inside the company. Lot of them, a lot more. And then, of course, like from Labkey, I'm pretty sure I forgot a lot of the names. but these were the main players involved so far. And I'm happy to take questions here.
How easy was it to create your data model from your spreadsheet? You've got a spreadsheet. Is your data model really just what was in the spreadsheet? So just the layers, or was it easy? Was it a complicated process?
It's all relative, isn't it?
Yeah.
I mean, it's yes, it was easy to a certain extent.
Sorry, so the question was how complex it was to create the data model which you're using in Labkey.
So creating the data model in principle was relatively easy, right? So because like when Ollie and myself sat down in the beginning, we said like, well, you know, we kind of know what we want, so we put together the first version. But then interestingly enough, of course, at the point where people understood what they potentially could do, they started to say, well, you know, in principle, I'm using these Excel files at the moment, and I'm just getting this data out. But actually, I would want to get this data out in addition and stuff like that. So it started really easy, and it got more complicated, and it's probably still getting more complicated. And once we have rolled it out, I'm pretty sure we'll revise it 20 times, because when people understand the power of it, because, you know, in drug development, it's a constant learning process, right? And I think people have understood at some point that this learning process is a lot easier if somebody else is combining the data for you instead of you doing it yourself. And so the tricky bit is, of course, you need to know the questions beforehand. And that's, you know, a lot of the questions, you know, Ollie or myself could really get beforehand, because, you know, we're involved quite deeply in the projects. I mean, this is not our day job, so to say. This is just, you know, a side project. So we're normally doing research. So we could get a lot of questions beforehand, but there are more and more coming. And at the moment, like all the constraints we have on the data model, all the combinations, we're still working on that, and it's getting more complicated.
Right. Have you tried to upgrade Labkey during the process of this work? Have you tried to upgrade to like the new stable release?
Yep.
We tried to augment data models in Labkey by augmenting the SQL tables. And during the upgrade process, there's inherent problems there. I just wondered if you tried to upgrade and if you had any problems yourself. Because if the mapping's not correct, for example, we're using the Java API to push data into Labkey. And if the mappings are not correct, the types are not correct, then you're going to have problems in the upgrade. I just wondered if you'd experienced any of that.
So far, I have to say the upgrades were pretty much okay. We didn't have any problems with that. Touch wood. I mean, I hope it stays like this. The thing is, like, we keep changing the model, and so we're moving the data across the different versions constantly anyway. And so the amount of data at the moment is, I mean, it's in principle, it's about, you know, 1 million data points at the moment, so it's not that much. So it's relatively easy to get it out, and we have some R scripts to load all the data in one bunch. And so what we normally do is when we go to a new version, or what we've done so far is, we just push the data into the system again when there are any problems. But so far the upgrades have been pretty much okay.
Can you talk a bit about the workflow tracking in the Labkey? So what components in the Labkey
Okay.
you adopted for this workflow?
So the question was about the workflow tracking, what parts we use in the Labkey system to do the workflow tracking. Actually, workflow tracking sounds great, right? And you would expect that I would say, yeah, we wrote our own module and everything. Well, you know, it's a couple of queries and lists. That's it. I mean, it's literally not more. It's a couple of lists and queries. No specific module or no anything, because it's passive, right? So at the end of the day, the workflow tracking just means it's a property of a molecule, and you like to know, or a property of an assay, or a property of something else, and then the user has to change that. So there's no automatic scripts at the moment which would change anything in the workflow. There's a predefined workflow for the molecules, so you have a certain menu to choose from, and then you have different hierarchy levels and stuff like that, and this is really only achieved through a couple of lists and queries.
So you mean you just build this relation workflow inside of your query?
Yes. All right. Thank you.
Thank you very much, Stefan.